Hello students, so we are continuing with the Boolean algebra chapter. In today's video we'll discuss about what is shorthand notation, or what is canonical form, and the methods associated with the canonical form. So we'll be seeing one of the method, that is SOP, sum of product form, right? So now what is shorthand notation? So using the shorthand notation we can find the mean term and max term of Boolean expression. So what is mean term and what is max term, I've already explained that in the previous video. So if you have not watched that video, please go and watch that video, understand what is mean term and max term. As I've said, that we'll be using a lot of this mean term and max term uh, notation. Okay, so you have to go and check that video and try to understand what is mean term and max term. Clear? So the following steps are used to form the shorthand notation. So what we do is that first we copy all the original term or expression. So the original Boolean expression, we copy it as it is. Then we substitute 0 for the complemented variable, so that if the variable is x, like example x complement, then we replace it with 0. But if the variable is not complemented, then we replace it with 1. Then what we do is that we convert the binary number. That means we convert it into binary number, into decimal number, since we know that in the Boolean algebra all the values that are assigned is 0 and 1 only, that is the binary numbers, right? So now what we do is that we convert it into decimal number, and then with subscript m, which stands for, small letter m stands for mean term, and capital M stands for max term, right? So what we do is that using this shorthand notation we find the mean term notation or the max term notation. We have already seen in the previous video that using the truth table we can express the Boolean expression into binary numbers and then decimal numbers, and using the truth table, and then finally we can find the mean term designation or max term designation. That was the mean term notation or max term notation, right? That was using the truth table, which was in the easier format, right? Now we will see how we can find the mean term designation or max term designation using the shorthand notation. So another method of finding the mean term notation. The first one was the truth, using the truth table. So now the second one is using this shorthand notation. So now find the mean term designation of x complement, y, and z complement. So using the shorthand notation we now find the mean term designation or the mean term notation. So here a Boolean expression is given, that is x complement, y complement, and z complement. So the solution is we substitute the complemented variables, that is x complement and z complement, with 0, and y, since it is non-complemented, we give the value 1, the binary value 1. So we get the binary numbers or word, that is 0 1 0. Alright, now after that what we do is that we find the decimal equivalent of this binary number. Since we have already discussed in the number system, I'm sure that all of you are familiar with how we get this convert a binary number into decimal equivalent, right? We multiply it with the power of the 2, since 2, that is binary, is composed of only 2 numbers, right? So we take 2 to multiply these binary numbers, so we get the value decimal equivalent as 2, right? So that is 0 1 0, which is 2. The decimal equivalent of this binary number is 2. So now the mean term designation or the mean term notation, decimal subscript equals to m2. So we have seen that in truth table, that if you see the truth table in the previous video, you will see that the decimal columns is 2 and the mean term designation will be m2. If the decimal number is 7, the mean term designation will be m7. So the number 2 represents the decimal equivalent. Okay, so this is how we find the subscript of the mean term designation using the shorthand notation. Clear? So this is also one of the methods, easy method, and another one of the easy method is using the truth table, right? Now canonical form. So what is a canonical form? A canonical form is composed of either mean term or max term expression. So it can be only of it can be comprised of only two things, that is, either it is completely of mean term expression or it can be of completely of max term expression. So now it is of two types, that is SOP or sum of product form, or product of sum, that is POS form. So today we shall be seeing what is a sum of product SOP form, canonical form. Okay, so sum of product is a canonical expression that is entirely composed of mean term. So whenever we have a canonical expression that is composed of mean term, that is sum of product form, right? So now we have to find the canonical form of the sum of product, right? So now in this example you will see that we use f as a function. Okay, so we saw that in programming also, using the function we are able to pass the values, right? So here also the f stands for function, which is similarly as we use it in the programming. Okay, we also use it in this Boolean algebra. So here x, y, z are actually your input variables, right? Your input variables which stores the value. So now f function will process all these input values which are stored in this variables x, y, z. So here f equals to, so this is a mean term canonical expression. So a mean term canonical expression. Why is it a mean term? Because you can see that we are using the dot operator, that is the logical AND. We are multiplying, so that is, this denotes that x into y into z, right? Okay, plus x into y complement into this is z. Okay, z complement plus x into y into z. Clear? So now to find its canonical SOP form, that is the designation or notation of mean term, we write in this format: f equals to, we use this summation to denote that the sum of. Okay, so this summation symbol is used to represent sum of. So here if you see the truth table in the previous video, where we get the mean term designation, you compare it with this mean term canonical expression. So that is x complement y x complement y and z, it will be m3, which represents, when in canonical SOP form it will be written 3, and then x y complement, and this is a z complement. Okay, it will be m4, so which will be written here as 4. Okay, and x, y, z, where all the values are 1 1 1, which is number 7, that is m7, so we write here 7. So you can see that it is very easy to get the canonical SOP form, that is a sum of product form. Now, as the name also suggests, sum of product form, which is comprised of mean term, right? You can see that this is the all of these terms are product. The variables are multiplied, right? X into y into z here, x into y into z, x into y into z. So what we do is that the product of these variables, we add it, sum. So sum, that is plus plus of product, right? So the product of these we add, product of all these three variables we add it. So that's why it is called as sum of product SOP form, and we get this canonical SOP form in this format, right? So the function, okay, equals to sum of 3, 4, and 7, right? Which is represented by this mean term notation m3, m4, and m7. Now, using a truth table, a Boolean function, that is f, output can be expressed by forming a mean term for each combination of variables, which produces an output 1 in the function, and taking OR of all the terms. So that is explained by this particular example. So here in this example we have a truth table expressing the function f, x, y, and z in SOP form. So now we have to find the canonical form. Okay, so now we have to find it in canonical form. So this is in SOP form, that is mean term canonical expression. So now we have to find it in the canonical form, that is the we have to find the summation canonical SOP form, right? So now this is the truth table. So as you can see in this truth table, we have three variables with the input values, and this f function we get based on these input values. Okay, now in some textbook, in the textbook, not all of the outputs are correct. Okay, so but since it is written here like this, so we have to follow in that format only, right? So now this is the solution uh, uh, table that is generated. So here from the given table, the function which produces 1 are, okay, so here we have to take the we find the mean term expression of from the function output. So this is your input value, okay, this is your input value from the variables x, y, z, and based on these input values we generate the output for this function f in this format, 0 1 1 1, like that. Okay, so wherever there is a value of 1, okay, value of 1, the output is generated as 1. Right, so here since there are two ones, okay, so it becomes like 0, and then here we get the value 0. Okay, so here it is written here, see, a Boolean function output can be expressed by forming a mean term. So we form a mean term like this, okay, for each combination of variables, and then we combine this, which produces an output 1 in the function. So wherever the output 1 is produced in the function, after that what we do is that we take the OR of all the terms. That means we all these mean terms, we take the OR function, that is the plus, we add all these mean terms. Clear? So this is represented here. So what we do is that in the first case, wherever the function produces the value 1, we find the mean term of that. Okay, we find the mean term. So here we find the mean term. So here where there is 0, okay, so in here where there is 0, the variable gets complemented. So that's why here 0, the variable gets complemented. So it will start from where the function is 1, is true. Okay, so here since it is 0, x becomes complemented, and here since y is 0, y becomes complemented. So we have x complement, y complement, and since z is 1, so z retains its own variable. Now again here, since x is 0, so x complement, y is 1, so y remains unchanged, z is 0, so becomes z complement. So you can see that wherever the value of f is 1, we find the mean term expression in this format. Then this is not given in your textbook table, but this is from your previous example, from your previous video, so I just showed this so that you can understand. So this is the designation. So that means the mean term notation, that is m0, m1, m2, m3, m4, right? So this is actually the decimal format. Okay, this is the decimal format, and also the mean term notation. So you can see that this x complement, y complement, z, in terms of the designation it is 1, and here it is 2, here it is 3, and here it is 7, right? So now from the given table, the function which produces output 1 are, so taking OR of all the mean term form, we can simplify the expression for above table as like, so we find the function. So since it's already in the question, okay, so function of x, y, z equals to, so now we multiply it with the function, right? 1 and the mean term, so that is 1 into x, this value, mean term value, plus 1 into, okay, plus 1 into this, plus 1 into this. So anyway, we get only the mean term values because we are multiplying it 1, right? So anything multiplied by 1, we get this value, only mean term value. So finally we get this mean term value. So now what we do is that to convert it into canonical form, we have to compare this mean term expression with the designation value. So we can see that this is equivalent to 1. So here the canonical form of this function xyz summation, so we write 1 comma 2 comma 4 comma 7. So if you see, we get 1 2 4 and 7, right? So this is how we find the SOP canonical form. Okay, in the next class I'll be discussing about the product of sum or POS form, okay, and how to find the POS canonical form. Yeah, so go through all these topics that I've explained today. Try and understand, okay, especially understand what is the mean term, max term, shorthand notation, the canonical forms, okay, SOP, all of this. All right.